Good morning, students. So, we have seen the complex number and quadratic equations, entire concepts and terminologies. Today, I'll be solving few questions based on the given chapter. Please try to understand each and every steps and try doing the same question by yourself without looking at the answers. You can try more questions also based on the same thing. So, the first question is, if a plus ib multiplied by c plus id multiplied by e plus if multiplied by g plus ih is equals to a plus ib, then show that a square plus b square multiplied by c square plus d square multiplied by e square plus f square multiplied by g square plus h square is equals to a square plus b square. This is the question from miscellaneous exercise question number 19. And the next question is question number 20. If in bracket 1 plus I divided by 1 minus I to the power m is equals to 1, then find the least positive integral value of m. So we have here two questions with me right now, and I'll be solving each and every question, that these two questions in front of you. You try understanding with the given steps. Question number 19, we'll take it first. Solution of 19. It is given that a plus ib, c plus id, e plus if, and g plus ih is equals to a plus ib. And they want a square plus b square. Remember, we have seen in the introduction part as well as the conceptual part of complex numbers that mod of z is nothing but x square plus y square. So this x square and y square is nothing but the real part and imaginary part, isn't it? The real numbers of the real as well as the imaginary. So here a and b are taken as the real as well as imaginary. So the square of this number means in the given question a plus ib, if I do the square, if I find the modulus of a plus ib, I'll get a square plus b square, correct? So following the same rule, we'll proceed. I'll find the mod of the LHS as well as the RHS. So mod is written as mod of a plus ib, c plus id, e plus if, and g plus ih. Closing a plus ib. As we know that mod of z1, z2, z3, z4 can be written separately as z1, z2, z3, and z4, and so on if there are n number of complex numbers taken together with the product. So I can write here separately as a plus ib, c plus id, e plus if, and g plus ih is equals to the mod of a plus ib is nothing but the square root of a square plus b square. Now taking the mod of these complex numbers together, we'll get the square root of a square plus b square multiplied by square root of c square plus d square multiplied by square root of e square plus f square multiplied by square root of g square plus h square is equals to square root of a square plus e square. Now squaring both sides, we get a square plus b square multiplied by c square plus d square multiplied by e square plus f square multiplied by g square plus h square equals to a square plus b square. And this is the final result of the given question number 19, students. So these are the step-by-step calculations for the given question. Try understanding the concept. The question is based on the modulus of a complex number. Okay. Now the next question is, if in bracket 1 plus I upon 1 minus I power m equals to 1, then find the least positive integral value of m. 1 plus I, 1 minus I. Solution of 20. 1 plus I, 1 minus I, power m equals to 1. Finding the least possible positive integral value of m. So you need to find the value of m here. Very easy question. I hope you all know about the conjugate. Conjugate of a complex number a plus ib is given by z power z bar equals to a minus ib. Okay. So finding the conjugate and multiplying the numerator and denominator with the same conjugate of the denominator, the value will be 1 plus I by 1 minus I multiplied by the conjugate of denominator 1 plus I, 1 plus I, using the equivalent fraction rule. In the numerator we have 1 plus I whole square by 1 minus I and 1 plus I. Power m equals to 1. Use the identity a plus b whole square, you get 1 plus I square plus 2I by, this is again another identity, that is 1 minus I, 1 plus I, a minus b, a plus b, which is a square minus b square. Put implies sign here because there is already equal to sign. Another implies sign. 1 minus I, 1 minus 1 plus 2I by 1 minus I square equals to 1. I square equals to minus 1. These two values get crossed up. We have 2I upon 1 minus 1 equals to 1. And the power is m, of course. I'm leaving this one. Everywhere I've left. So power m. Do not forget this. The power is m. It implies 2I upon 2. Power m equals to 1. 2 gets cancelled. I power m equals to 1. Now what could be the possible value of m? To get the value 1 for I, it will be I square is minus 1, right? So if I do I square, it becomes plus 1, right? Because I square is minus 1, so minus 1 square is plus 1. That means the power to power multiplied, it gives you 4. I power 4 will be 1. So here m will be equals to 4k, where k is some integer. If you take k as 1, then also you get the value as 1. If you take k as 2, say if I take k as 2, I power 8 is equals to what? I power s square power 4. So this is minus 1 power 4. Again, you get positive 1 only. I hope you have understood these two questions, students. Try solving more questions based on these modulus and conjugates. And for any problems, you can ask me in the virtual class. Thank you.